Good morning, students. How are you all? Fine. I also fine. So, students, today we will do some questions, some NCRT question of Unit 7, that is alcohol, phenol, and ether. So, our first question is, while separating a mixture of ortho and para-nitrophenol by steam distillation, name the isomer which will be steam volatile. Means if we have orthonitrophenol. Orthonitrophenol means at one nitro group, it at two position. Orthonitrophenol and para-nitrophenol. Para-nitrophenol means nitro group will be at fourth position with respect to the alcoholic group. So here which one will be the steam volatile? Here orthonitrophenol is steam volatile. Why it is steam volatile, students? It is steam volatile due to chelation or intramolecular hydrogen bonding. What do you mean by the chelation? Here you know very well here intramolecular hydrogen bonding take place. Here intramolecular hydrogen take place between hydrogen of the alcoholic group and oxygen of the nitro group. This, if hydrogen bonding take place in same molecule, then it is known as intramolecular hydrogen bonding. And students, after forming the hydrogen bond, here a ring is forming. This ring is forming here. And this formation of ring is known as the chelation. Formation of ring is known as the chelation. So because orthonitrophenol form intramolecular hydrogen bonding, so they do not form hydrogen bond with other molecule of the orthonitrophenol. But if we talk about para-nitrophenol, let us consider this is one molecule of para-nitrophenol and this one is the second molecule of para-nitrophenol. So they form intramolecular hydrogen bonding, not intra, they form intermolecular hydrogen bonding. This, if hydrogen bonding take place to different molecules, then it is known as the intermolecular hydrogen bonding. It can form hydrogen bonding with other molecules. Again, it can form with other molecule because para-nitrophenols are forming the intermolecular hydrogen bonding, so they are more stable as compared to orthonitrophenol, because in case of orthonitrophenol they are forming intramolecular hydrogen bonding. Hydrogen bonding take place in one molecule only, so they do not form bond with other molecule of the orthonitrophenol. So here orthonitrophenol is less stable as compared to para-nitrophenol, so it is steam volatile and hence can be separated by steam distillation. Para-nitrophenol, which is not steam volatile because of the intramolecular hydrogen bonding. So here our question is, in between ortho-para-nitrophenol and orthonitrophenol and para-nitrophenol, which one is more stable and which can be separated by Steam volatile. So here because it is less stable. Why it is less stable? Because it is forming the intramolecular hydrogen bonding. So it is steam volatile. So it can be separated by the steam distillation method. Our next question is, students, give two reactions that show the acidic nature of the phenol. Write down two reactions that show the acidic nature of the phenol. Compare acidity of phenol with that of the ethanol. First one, write down two reactions. Our first reaction, phenol react with sodium to give sodium phenoxide and liberating hydrogen gas. So if we have phenol, and if we do reaction of phenol with sodium metal, then they produce sodium phenoxide plus hydrogen gas. Student, you know very well about the property of the acid. Acid when react with metal, then they produce salt plus hydrogen gas. Here production of hydrogen gas is taking place when phenol is reacting with a metal. And you know very well when acid react with metal, then they produce hydrogen gas. Here, phenol after reacting with a metal, it is producing the hydrogen gas. So it shows that phenol is acidic in nature. Phenol is acidic in nature. It is clear to you or not? Our next reaction is when phenol react with sodium hydroxide to give sodium phenoxide and water by the product. Here, when it react with sodium hydroxide, this is formula of sodium hydroxide, then it gives sodium phenoxide plus water. Student, you know very well about the neutralization reaction, acid-base neutralization reaction. When acid and base react with each other, then they form salt and water. And this reaction is known as the neutralization reaction. So here you can see that, here you know very well sodium hydroxide. This is the strongest base. After reacting with phenol, it is giving us water. Means which shows that this phenol is acid. Because acid and base react with each other, then they form salt plus water. Because after reacting with base, it is giving us water and salt. So this shows that this phenol is acidic in character. It is clear to you or not? Yes, students. Now compare acidity of phenol with that of the ethanol. So in between phenol and ethanol, which one is the more acidic? Here, acidity of phenol is more than that of the ethanol. Why it is? This is because after losing a proton, phenoxide ion undergoes resonance and gets stabilized, where ethoxide does not. This is phenol. After losing one proton, it will convert into the phenoxide ion. And students, you know very well, phenoxide ion is resonance stabilized. Phenoxide ion, it is resonance stabilized. We can form resonating structures for this one. Here, this is phenoxide ion. So here these electrons can form bond and they can move at this position. Then double bond will be there. Then this bond is shifting here. So negative charge will goes on this carbon. Further this will come here and this bond here. Then what will happen? Again we are not making any change here. Here these electrons are shifted here, so double bond, and these electron pair are shifting here. Again this electron pair is shifting here, and this will move to at this position. Finally this will shift here and this will shift here. So student, you can see phenoxide ion is more stable. Why it is more stable? Due to the resonance stabilization, because it shows the resonance. Okay, so it is more stable. But if I talk about the ethanol, ethanol is C2H5OH. After removal of proton, after donation of proton, it will give us ethoxide ion. And here this negative charge will attain only at one oxygen. It is not delocalized. So this ethoxide ion, it is not resonance stabilized. So student, due to the stability of the phenoxide ion, phenol is more acidic as compared to the ethanol. This question is clear to you or not? Yes. Now our next question is, explain why orthonitrophenol is more acidic than orthomethoxyphenol. Orthonitrophenol. This one is orthonitrophenol. It is more acidic as compared to orthomethoxyphenol. Orthomethoxyphenol. Why it is? Student, you know very well, if electron withdrawing group increases, then acidity also increases. Acidity is directly proportional to the number of electron withdrawing group attached to the phenol. Here, nitro group is an electron withdrawing group. So this existence of this group in ortho position decrease the electron density in OH bond. What will happen here? Here this nitro group, this one is the electron withdrawing group. So it will attract the electron towards itself. Here this one is electron withdrawing group. So it will attract electron towards itself, which make this bond between oxygen and hydrogen. It will weaken this bond. So this bond can break easily. So it can lose H positive ion easily, and which donate the H positive ion easily means it will be more acidic. Okay, but here this methoxy group, this is the electron releasing group. means it donate the electrons. Here it is giving the electron to this. Okay, so what will happen? It is increasing the electron density at oxygen. It is increasing the electron density at oxygen. Due to more electron density at oxygen, it will not take electron from the hydrogen, so it do not release the H positive ions easily, so it is less acidic as compared to the orthonitrophenol, or we can say electron releasing group. If number of electron releasing group increases, then they decrease the acid behavior of any compound. So students, here nitro group is electron withdrawing group, so it increases the electron density in OH bond. So it is easier to give a proton. And students, after taking the electron by this nitro group, when the phenoxide will form, after losing the electron, it will form the phenoxide ion. And in second question, we have already discussed that phenoxide are the resonance stabilized. Okay, so which also promote it for the best acidic behavior. Now our next question is preparation of ether by acid dehydration of secondary and tertiary alcohol is not a stable method. Give reason. Students, the synthesis of ether with dehydration of alcohol is a bimolecular reaction, means it follows the SN2 mechanism. First of all, you should know that what is the dehydration process. If you have alcohol, if you do dehydration in presence of the protic acid, means which give H positive ions, reaction will take place at low temperature, around 413 Kelvin temperature we will take. Then what will happen? Here formation of ether take place. Here formation of ether take place. This reaction is more stable for the preparation of symmetrical ether. Students, this reaction follow the SN2 mechanism. You can see the mechanism of the reaction. First of all, what will happen? We have alcohol. Here we are taking ethanol. We are taking the presence of acid, so they will release H positive ions. Then it behave like electrophile, so it needs some electron. From where it can take the electron? Availability of the electrons is on oxygen. So it can take the electron from here and it can form bond with this one. Then means protonation take place here. It is forming. Protonated alcohol is forming here. Students, it is not stable. Why it is not stable? Because here positive charge is on it, more electronegative element is on oxygen. So what will happen? Again, other unit of the alcohol will promote this one, that will support this one. So what will happen then? This oxygen gives the electron to this carbon, because here water is good living group, so it will take the electron from this carbon, so positive charge will attain on this carbon, so this oxygen will support this one. Then removal of water take place from here. Removal of water take place from here. Then what will happen, students? CH3, CH2, OH. Again it is forming bond with this carbon, CH2, CH3. Because again oxygen is donating the electron, so positive charge will attain on this oxygen. Again it is not stable, so it will take the electron from this hydrogen, and finally we will get CH3, CH2O, CH2, CH3, means we will get ether finally. So student, you can see that here attack is taking place from backside. Backside attack is going on here. Backside attack means, and reaction is bimolecular because it is depend on the concentration of both. So here it is bimolecular reaction. And attack is taking place from backside, means they are following the SN2 mechanism. And student, you know very well